When it comes to Jupiter, how can one miss the mighty Great Red Spot? The largest planet in our solar system hosts the biggest and most violent storm known to date. We don't really know for how long it's been there on Jupiter, but it's been raging since Robert Hooke first discovered it through his telescope back in 1664. Over the years, several missions have explored this mighty storm on Jupiter. During their brief flybys, space probes such as Voyager 1, Voyager 2, and the Cassini spacecraft studied it. From Earth, the Hubble Space Telescope has been making observations of Jupiter and the Great Red Spot. Recently, data from Hubble suggested that the spot is shrinking. The storm was once big enough to engulf 3 Earth-sized planets inside it. Today, it can fit just over 1 Earth-sized planet. Not only that, the storm has sped up over the last decade. Hubble's data from 2008 to 2020 showed that the wind speeds at the edges of the Great Red Spot have increased by 8%. The anticyclone has also changed its shape, going from oval to circular. Making detailed observations of the Great Red Spot from Earth is challenging. Even the biggest telescopes on Earth or the ones in space can probe the storm only up to some extent. To really see what's happening inside the storm, we need to visit Jupiter and make continuous observations. And this is exactly what NASA's Juno spacecraft has been doing. Juno was launched in 2011 and reached Jupiter 5 years later. It has been orbiting the planet and continuously exploring Jupiter's magnetosphere, cloud tops, radiation belts, and the composition of its moons. Juno is a mission full of daring assignments, but unfortunately, Jupiter's deadly radiations make it extremely difficult for spacecraft to get too close to the planet. However, after 5 years of observations, Juno has revealed what lies beneath the thick clouds of Jupiter, and particularly inside the Great Red Spot. As it turns out, Jupiter's Great Red Spot is not only wide, but goes way deeper into the planet, more than anyone had expected. Data from NASA's Juno spacecraft has shown that the behemoth storm extends as much as 310 miles beneath Jupiter's cloud tops. How deep is that? Well, it's as tall as the International Space Station is above the surface of our planet. This means if a storm that tall raged on Earth, its upper end would be at the ISS, 500 kilometers above us. So, now the interesting question is, how did scientists measure the depth of the Great Red Spot, and what did they see happening in there? Questioning is an important part of understanding something, and that's why I would like to tell you about the sponsors of this video, Unacademy. What if I told you you could ask about any problem from your book and get its solution instantaneously? You heard that right. See, it's vital to know the pattern of exams before entering the exam hall. That's why Unacademy has brought a comprehensive preparation package with the Ask a Doubt feature and practicing with Emerge Mega Mock Board exams. Now this is a special mock test because if you top in it, you'll win prizes up to worth 15 lakh rupees. Top rankers will get MacBook Air, iPad Pro, OnePlus 9, iPhone 12, laptop, headphones, and Unacademy branded trophies and goodies. Here are the details of the next mock test. That's not all. Unacademy also has an Ask a Doubt feature in which you ask your doubts 24/7. If you ask 10 doubts, you'll get 15 days of Unacademy plus subscription for free. This offer is valid for CBSE Class 6 through 12, Maharashtra State Board, IIT, JEE, NEET Foundation, and NTSE categories. To use the Ask a Doubt program, all you have to do is go to the Ask a Doubt feature, click Upload the image of doubt, and select the subject. This program is valid till 28 November 2021. You can ask unlimited doubts and get instant video solutions from India's top educators, both in Hindi and English. So don't miss this golden opportunity to prepare and win prizes. The link is given in the description, and you can enroll for free. Also, you can use my unlock code called SECRET and get 10% off on any Unacademy subscription. Coming back to Jupiter. These findings come from two teams of researchers. One team measured the Great Red Spot's gravity. They wanted to know if the storm's gravity was influencing Jupiter in any way. The idea was simple. Juno's gravity science instrument was turned to the 16,000-kilometer-wide storm to see if it left behind any fingerprints on Jupiter's gravitational field. This assessment was not a part of the original Juno proposal. However, investigating a planet's gravity to study its atmosphere is not new. A couple of NASA satellites have done the same on Earth. Gravity instruments can also see deeper into the atmosphere than other instruments tend to see. This just had never been done with the Great Red Spot. The assignment was a gamble. Scientists were not sure that they would find something substantial. The Great Red Spot might be a giant, but it's a drop in the bucket of Jupiter's total mass. But the researchers did indeed pick up fluctuations in Jupiter's gravitational field, enough for them to get a handle on the storm's depth, 500 kilometers. And the Great Storm seems to be fed by jets that reach far deeper, as much as 3,000 kilometers. While the first team probed the spot by making gravitational measurements, the second team explored the storm using Juno's microwave radiometer. It's an instrument that probes the planet's atmosphere with microwaves. These scientists wanted to look deep into the storm to see how it ticked vertically. They found that the Great Red Spot and other such storms on Jupiter stretch far down, with participation in drafts at unprecedented depths. In addition, they found signatures of these phenomena below Jupiter's cloud level, beneath which the ammonia and water in the atmosphere are expected to condense. Together, the gravity and microwave measurements hint that Jupiter's upper atmosphere is meaningfully connected to these depths. The Great Red Spot is actually an anticyclone raging on Jupiter. The planet is home to several similar cyclones and anticyclones. The new results show that the cyclones are warmer on top, with lower atmospheric densities, while they are colder at the bottom, with higher densities. In contrast, anticyclones, which rotate in the opposite direction, are colder at the top, but warmer at the bottom. In addition to cyclones and anticyclones, Jupiter is known for its distinctive belts and zones, white and reddish bands of clouds that wrap around the planet. Strong east-west winds moving in opposite directions separate the bands. Juno previously discovered that these winds, or jet streams, reach depths of about 3,200 kilometers. Researchers are still trying to solve the mystery of how jet streams form. However, data collected by Juno's instruments during multiple passes reveal one possible clue: that the atmosphere's ammonia gas travels up and down in remarkable alignment with the observed jet streams. NASA's Juno spacecraft has been making continuous observations of Jupiter since 2016. In 2021, the mission received a 5-year extension. If all goes according to plan, Juno's orbital path will move to take the probe over the planet's north pole and away from the Great Red Spot, which is farther south. But Juno's instruments will get the chance to watch other curiosities, such as Jupiter's cryptic polar cyclones and the 4 Galilean moons. Jupiter holds the secrets of the early solar system, and exploring the planet is crucial to understanding how the solar system really formed.